Let us understand complete concept of using chain rule combined with power rule. Here are 6 examples to practice with alternate methods. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss how the chain and power rule is applied with the help of 6 examples. We'll also try to understand when to apply this rule and how to apply this rule. We'll actually solve each question with 2 different methods as they are popular in all the students. So here are 6 questions for you. You can make a note of these 6 questions and answer. This video is specially meant for students who need to understand and have good foundation for calculus. So let us first understand when to apply the chain rule and how to apply. So whenever we have a composite of function, a composition of function, that is function within a function, in that case chain rule is applied. So for example, here we have an input which goes to a function g, and that output, which is g of x, gets into another function. In that case, the output will be f of g of x. So it becomes a composite function. You get the idea. For example, if output g of x is, let us say, equal to x plus 1 and f of x is square root of x, in that case, what happens? In that case, for any x which comes as an input, after the operation is performed by the first function, the output is, the number is increased by 1. And when the same operation is applied by f on the input x plus 1 this time, the output will be square root of x plus 1. So f of g of x is equal to square root of x plus 1. Do you see that? So it involves 2 different functions, right? Then we use the chain rule. Perfect. Now, so that is what composite of function is, which I was trying to explain you. So here, a note for you. The composition of function f of x with g of x can be written as f of g or f of g of x. Here f of x is the outside function and g of x is the inside function, also called the argument. In this case, the output of g of x becomes the input of f of x. You see, the output of g of x becomes the input to f of x. Here's an example of a function which is different from what I took. If you have a function square root of x squared minus 4, for example, it can be treated as a composite function, where the inside function x squared minus 4 can be f of u, for example, right? I mean, g of x could be x squared minus 4 and f could be square root of that, right? And so you have a composite function. You get the idea. So that is the basics. Now, when you have such a case, then to find the derivative, we have a formula. One which we use directly with function notation. F d dx of f of g of x is derivative of outside function times derivative of inside function, right? It is important to note that both derivatives should exist, otherwise you will not get a result. Now, in the second notation, you can also say dy dx is dy du times du dx, right? Where the inside function is u. You get an idea, right? So du dx is rate of change of u with respect to x, and dy du is rate of change of y with respect to u. dy dx is the rate of change of y with respect to x. So then you finally get dy dx as product of the two derivatives, right? Let's take up these examples one by one and then understand what are we trying to say. So the very first example for you is y equals to 3x minus 4 to the power of 10. So let's look into this. We have y equals to 3x minus 4 to the power of 10. Now, when you are going for a power rule, you know how it is applied. Let me write down the power rule here for you. Power rule is that if y is equal to a times x to the power of n, then the derivative is a times n times x to the power of n minus 1, correct? So, but here we got a function inside, correct? So how do we apply the chain rule? Let us see that. So one method, which you'll say method 1, works like this. You can say let the inside function be u. So u equals to 3x minus 4, correct? So now we can differentiate u with respect to x. So we have du dx as equal to 3, right? Because the constant derivative is 0. Since u is 3x minus 4, I could write y as equal to u to the power of 10, correct? Now y becomes function of u. So what is dy du? Well, dy du will be 10 times u to the power of 9. So we got dy du in terms of u, right? Now what is u equals to? U is 3x minus 4 to, that is 3, right? 3x minus 4 is u. So replace u with 3x minus 4 and write 9, the derivative. Perfect. So I hope it is absolutely clear to now. We are actually finding what is dy dx, right? Differentiate y with respect to x. Now that is equal to dy du, since we wrote it like this, times du dx, correct? So we have both, right? We have du dx and dy du. So dy dx is equal to dy du is, this is dy du, correct? So we'll write this 10 3x minus 4 to the power of 9 and du dx is 3, correct? So we'll multiply this by 3. And now we can simplify and write this down as 30 times 3x minus 4 to the power of 9. Is that clear to you? So you see how we have utilized actually the power rule to get this derivative. So once again, power rule is what? Power rule is if the function f of x is equals to a times x to the power of n, then the derivative will be equal to a times n times x to the power of n minus 1, one power less. And therefore, u to the power of 10, derivative was 10 u to the power of 9. So I hope the concept is clear, right? Now let's move forward and use the second. Now the second rule of this same function we have taken. So if we have a function of function, as we said, f of g of x, right? Now if you want to find the derivative of this function, then it is derivative of inside function, right? So y equals to 3x minus 4 to the power of 10. I could write down this derivative as dy dx, or we could also use the prime notation as outside function is 10 times 3x minus 4 to the power of 9. So we applied the power rule. Now we have to do the derivative of inside function, which is 3x minus 4. You get the idea. Which is substituted as u in the previous case. So now we get 10 into 3x minus 4 times the derivative of 3x minus 4 is 3, well, to the power of 9. And then we get our result 30. 3x minus 4 to the power of 9. Do you see? Exactly the same result. I hope the concept is absolutely clear. In case you want to learn from me, you can always send an email on the address given. Most of my students are right there on top of their class getting awards and scholarships, like Akshat.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel.
So I hope the concept is absolutely clear, right? So that was a starter. Now let us take up the other questions one by one. So are you there with me, right? Get ready for this. So which method did you like? We'll actually do all these questions with both the methods, okay? So we are now given y equals to square root of 25 minus x squared. So you could write u as equal to 25 minus x squared, correct? In that case, y will be equal to what? Y will be equal to square root of u, right? Correct? So now what is du dx? Well, du dx is minus 2x. And what is dy du? Dy du is, now some of you write this as u to the power of half and then do the derivative, right? So let's do like that. Half of u to the power of minus half, correct? Which you will write as 1 over 2 square root of u. Is that clear? Now, what is dy dx, which you really want to find? That is equal to dy du times du dx, correct? So dy du, which is here, I could write u, replace u by 25 minus x square, right? So we get 25 minus x square, correct? So let's now multiply the two derivatives, which is 1 over 2 square root of, this was 25 minus x square times the derivative, which is minus 2x du dx, right? So you can combine the two, simplify, 2 gets cancelled, and therefore you get your result as minus x over square root of 25 minus x square. Is that clear to you? Correct? So that is how we have done the derivative of square root 25 minus x squared using one of our methods, and that is substitute a variable, right? So we use substitution here. Now the second method is kind of direct. So let's use the second method now. The function y is square root of 25 minus x squared. So what is dy dx? We'll apply the chain rule. So dy dx, first let me rewrite this as many students write. I actually normally write directly to the power of half, right? So dy dx will be, applying the power rule, half 25 minus x squared to the power of half minus 1, which is minus half, correct? Which you will write times the inside function, which is 25 minus x squared. So d dx of 25 minus x squared. Clear? Now, let's rewrite this. Half 25 minus x squared to the power of minus half. This will come in the denominator. So I could write this as 1 over 2 square root of 25 minus x squared. Correct? And what is the derivative of 25 minus x squared? Minus 2x, right? Times minus 2x. Is that clear to you? So we can now multiply and simplify these. As we got last time, we have the same result. It was expected, right? So we have dy dx as equal to minus x over square root of 25 minus x squared. Does make sense to you? You see how we are done? So this is a preferred method you can directly do when the questions are simpler, right? Let's take up another example. So I hope is giving you good practice, right? So this question is very similar to what we just now did, right? So using the first method, I could write the inside function as u, which is 2x squared minus 1, right? And then du dx will be 4x. Perfect. The outside function can now be written as y equals to cube root of u, right? Cube root of u. So I can write like this. Clear? So what is dy du equals to? Dy du will be 1/3 of u to the power of 1 over 3 minus 1, which is minus 2 over 3. So is that clear to you? Now, we could replace u with 2x squared minus 1, right? So we get 1/3 of u, which is 2x squared minus 1 to the power of minus 2 over 3, correct? So if you want, you can rewrite this as 1 over 3 cube root of 2x squared whole square means I'll write them in brackets. Is that clear to you, right? That is how you write. And now finally, we could write dy dx as product of these two. So that is dy du times du dx. Is that clear to you? So dy du is all this 1 over 3 cube root of 2x squared minus 1 whole square. Is that clear to you? Times 4x. So now finally, we could write this as 4x over, which is the same thing, 3 cube root of 2x squared minus 1 whole square. Is that clear to you? So that is how you'll find the derivative of this function using chain rule, right? Now let's use the direct method of doing it, which is dy dx will be what? Derivative of outside function, which is 1/3 of 2x squared minus 1 to the power of 1/3 minus 1 minus 2 over 3, right? Times the derivative of inside function, which is 2x squared minus 1. Clear? Now we can write this as 1/3, and this expression is 1 over cube root of 2x squared minus 1 whole square, right? Times derivative of 2x squared minus 1, which is 4x. And so we get our final answer as we got last time, 4x over 3 times cube root of 2x squared minus 1 whole square as our answer, right? So that is how you're going to find the derivative. So I hope both these steps are absolutely clear. One by substitution, the other one in a chain rule, correct? Now here is the fourth question. I hope by now you have got good idea. But in this question, what we have done is we have complicated the problem a bit. So here you need to simplify first and then do. So how will you simplify? See, 1 minus square root x over x. So I could write this as 1 over x minus square root of x over x, correct? Everything to the power of 4, which is 1 over x minus 1 over square root x. Does it make sense to you? Perfect. You could also think about writing this as x to the power of minus 1 minus x to the power of minus half. Everything to the power of 4. Make sense? So you could actually see the equation in this form and then find the derivative. First step is simplify. Using our first method, where we are substituting u as the inside function, in this case x to the power of minus 1 minus x to the power of minus half. So what is du dx? So du dx is basically equal to x to the power of minus 2, and here you get minus 1, right? Minus, you get minus half times x to the power of minus half minus 1, which gives you minus 3 by 2. Is that clear to you? Which you could write as minus 1 over x squared, and here minus and minus becomes plus, and you get 1 over 2. This is cube root of x squared, right? Is that clear to you? So that is the inside function. Now let's look into the outside function, which is now y equals to u to the power of 4. So then what is dy du equals to? 4 u to the power of 3. Is that clear to you? Where u is all this, right? Which is 4 and u is 1 minus square root of x over x to the power of 4. Make sense? So once you know this, you can now write down what is dy dx. So dy dx is product of dy du and du dx, right? So here you have dy du, which is 4 times 1 minus square root of x over x, and multiplying by du dy, which is all that, right, all this, which is minus 1 over x squared plus 1 over 2 times cube root of x squared. Make sense? So that is how you are going to get the answer, correct? Now let's again do it using the chain rule. So we are given this expression, which we actually simplified and wrote as what? We wrote as 1 over x minus square root of x over x to the power of 4. So that is x to the power of, okay, let's go one more step. 1 over x minus 1 over square root x to the power of 4, which is x to the power of minus 1 minus x to the power of minus half over 4, right? So I've given the full form so that you can use whichever is good for you to use, right? Okay. So let's find dy du. Dy dx. Chain rule, right? So we'll have power rule first on the function, which is 4 times 1 minus square root of x over x to the power of 3 now, right? Times the derivative of inside function. So this function inside I have rewritten as simplified form, right? So that's easy for us to find the derivative. So I am writing this in this form, x to the power of minus 1 minus x to the power of minus half, correct? So that gives us 4 times 1 minus square root of x over x whole cube. Derivative of this will be x to the power of minus 1 derivative is minus 1 over x squared as we did last time, and this will be plus half comes, right? And x to the power of 3 by 2 minus, so I'll writing it here, right? So x to the power of 3 by 2. I could write like this also. Does it make sense to you? So that is how we can find the derivative. Both are the same results, okay? Now let's move on and take up next question, which is y equals to pi over square root of x squared plus 1. Now how am I going to solve this? Now in this case, pi is a constant. You remember, pi is a constant. Correct. So let's use u as equal to x squared plus 1. Correct. If u is x squared plus 1, then what is y equals to? Y will be pi over square root of u, right? Which you can also write as pi times u to the power of minus half. Makes sense? Correct? So from here now, let's write down the derivatives. Du dx is equal to 2x and dy du is equal to what? Pi is a constant, correct? U to the power of minus half means minus half times u to the power of minus 3 by 2. Clear? So you can now write dy dx as dy du times du dx. dy du is all this, which is pi times minus half. So I'm writing minus here and divide by 2. Minus pi by 2 u to the power of minus 3 by 2 times 2x. Now we know what u is. So I'm writing this as minus pi by 2. U is x squared plus 1. So x squared plus 1 to the power of minus 3 by 2. Do you see that? So we get our result. Now, most of the time, you should not be writing with negative powers, and therefore, you will rewrite your answer dy dx as equal to minus pi on the top, and in the denominator, we have 2 times, and that really means cube root, right, of x squared plus 1 whole square. So that becomes the answer. Is that clear to you? Perfect. You see how we did it, right? Correct. Now let's do the alternate method. So you can do it now yourself. So what is dy dx? Derivative of outside function, which is basically what? Let's rewrite this as pi times x squared plus 1 to the power of half, correct? Minus half, sorry. So this pi is a constant, right? Now derivative of outside function is minus half times x squared plus 1 to the power of minus half minus 1 minus 3 by 2, correct? Times derivative of inside function, which is x squared plus 1. So that gives you minus pi by 2 x squared plus 1 to the power of minus 3 by 2, and this derivative is 2x. Correct? So 2 and 2 will cancel. So I'm this time simplifying and writing my answer as minus pi x over all this, right? Which is cube root of x squared plus 1 whole square, right? Do you see that? So I think last time we forgot to write 2x, right? So this we forgot, right? So you have to multiply this by 2x, and 2 and 2 cancel, right? So we do get the same answer. We forgot to write 2x here. Correct? And therefore we get the same answer, which is minus pi x over cube root of x square plus 1 whole square. Right. So it's good. When we rewrite, you see the answer. Correct? Does it make sense? So that is how you should be doing it. Let's move on and take the last question now. Now in the last question, we have y equals to square root of 100 minus square root of x square minus 2. Now you can do it either way you want. We'll actually do with the chain rule this time, okay? So I'll do it once with the chain rule and I'll leave it for you to do it in alternate ways. So what is dy dx equal to? Some of you would like to rewrite this as 100 minus square root of x square minus 2. This to the power of half, right? And also you could write inside also to the power of half, correct? So dy dx will be half outside function, first I am taking half, and we get everything which is inside as such to the power of minus half. Is that clear to you? Times derivative of inside function, which is 100 minus square root of x square minus 2. Is that clear to you? So this portion can be written as 1 over 2 times square root of all this, which is 100, minus square root of x square minus 2, correct? Times the derivative of this is what? Half. So let's do the derivative of this, which is half of square root of x square minus 2, right? Times the derivative of inside function, d dx of x square minus 2. Do you see that? So there are 3 chains in it. Now we'll write down our final answer, which is all this 1 over 2 square root of 100 minus square root of x square minus 2 times 1 over 2 square root of x square minus 2 times, this is 2x. Do you see that? Now that can be simplified and then you write down the expression after cancelling this 2. So you got x on the top, right? So we have x on the top. And in the denominator, we have 2 times square root of the given function, which is 100, minus square root of x square minus 2, correct? Times square root of x square minus 2. So that becomes the answer. Is that clear to you? Perfect. So with this, we have actually seen how do we combine the power rule with the chain rule, right? And I hope you have learned different strategies to do it. Feel free to write your comments and share your views. In case you like and subscribe to my videos, that'll be great. And in case you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best.